Welcome to the GCSE Physics tutorial for topic P5 Forces. This tutorial will cover part 4, describing motion. First of all, there's some calculations you need to know. Speed. Speed equals distance divided by time. Now, because speed doesn't have a direction, it's a scalar quantity. Velocity is the same as speed but with direction and therefore is a vector quantity. Some examples of common speeds. So walking might be 1 to 1.5 meters per second, running is a faster speed, a car, and the speed of sound, which is 330 meters per second in air. Acceleration. This is measured in meters per second squared, and it's calculated by the change in velocity divided by the time. You also need to know that uniform acceleration is the same as constant acceleration, as shown in the calculation below. First of all, distance time graph. So a distance time graph has a distance and time on the axes. On these graphs, a flat line means the object's stationary, so not moving. When it goes straight and uphill, it means it's going at a steady speed, as shown in the diagram. The steeper it is, the faster it's going. When it curves downwards, that means acceleration, and when it curves upwards, it means deceleration. If it levels off, it means it's slowing down. If you want to find the speed of an object at a particular point, you would just find the gradient, as shown below in the diagram, to find out distance divided by time to give you speed. Now, here's an example of distance time graph. As you can see, at the beginning of this journey, the object is accelerating because it's curving downwards. Then they go and get a steady speed. Then they're decelerating, and then finally they're still or stationary. Velocity time graphs are different, and this time the axis says velocity and time. This time, when the line is going up straight, that means the object is accelerating constantly. When it's flat, it means a steady speed. When the line is going back down, it means constant deceleration, and when it's on the bottom of the axis here, it means it's stationary. To find out how far an object's travelled, the distance, you would look at the area underneath the graph. If you pause the tutorial now and try and describe both journeys in these graphs. So in the first graph, you can see the object accelerates, then travels at a steady speed, then starts to slow down, and then finally stop. In the second graph, it's a very similar journey, but the picture looks different because it's a velocity time graph. So at first it's constant acceleration, then travelling at a steady speed, then constant deceleration, and then finally at the bottom here, stationary. In summary, we've looked at describing motion.